So let's look at some short examples of graphing relations and functions. In Hawks, they will be giving you pictures and then asking you to find the domain and range. Just for two examples, I'm going to go to Hawks here in a second, but for two examples, I just want to graph them and then talk about their domain and range. So here, this first one, graph the following relations. Do they constitute functions? Give the domain and range. So remember that the first coordinate is your input and the second coordinate is your output. I think I was using red for input. So the first coordinate is your input. The second coordinate is your output. Now these are graphed this exact same way we were doing points before. I'm just writing this in and out so that we remember what these mean in terms of relations and functions. All right. So this relation, I don't know what the actual rule itself is. All I know is that 4 maps to 1, -3 maps to -2, 5 maps to 0, and 6 maps to -2. Okay, so I'm going to use dark blue to graph these. So 4, 1, that's horizontal 4, vertical 1. So 1, 2, 3, 4, 1, -3, -2, 5, 0, and 6, -2. So there's the graph of my relation. Now the domain is all the stuff that goes in. So 4, -3, 5, and 6, right? The range is all the stuff that comes out. So 1, -2, 0, and then -2 again. I don't actually have to list -2 twice. I can just list it the one time. All right, so there's my graph. There's my domain and range. Does it constitute a function? So function is one output for every input. So one way that you can sort of visualize it is you can write things in columns. So let me do that. So if I had 4 maps to 1, -3 maps to -2, 5 maps to 0, and 6 also maps to -2. So when I see this, I see, oh, well, there's 2 ways to get to -2, but there's only 1 arrow coming from each of the things in the domain. There's my domain. There's my range, right? Yes, it is a function. Okay. So for B, let's look at -3, 1, 2, 4, 1, 1, -3, 3. Again, I don't know the rule of the relation. I just know that in goes -3, out comes 1. In goes 2, out comes 4. In goes 1, out comes 1. In goes -3, out comes 3. Okay, so in goes -3, out comes 1. In goes 2, out comes 4. In goes 1, out comes 1. And in goes -3, out comes 3. Okay, so here's my graph. The domain is all the stuff that goes in. So I accidentally have an extra comma there. So -3, 2, 1, and then -3 again. I don't have to list the -3 again. The range is all the stuff that comes out. So what comes out is 1, 4, 1, I actually already have listed, and 3. All right. So is this a function? No, right? Because sometimes if you plug in -3, you get 1. Other times when you plug in -3, you get 3. So not a function. If we draw the columns again, -3 goes to 1, 2 maps to 4, 1 maps to 1, and -3 maps to 3. So here's the problem. There are 2 arrows coming from -3. So this is not a function because of -3, 1 and -3, 3. That's my problem. Okay, so I do this example to motivate the next thing that we talk about, which is what we call the vertical line test. So here's those 2 points represented on the graph, right? These are the 2 problem points. Problems. What's their relationship? Well, they lie on a vertical line. So as long as there's not a vertical line that would intersect your function more than once, or your graph more than once, then you are a function. So this gives us the vertical line test. So a graph represents a function provided that no vertical line intersects more than once. All right, that's my vertical line test. So on this one, on B, not a function because vertical line intersects more than once. On the previous one, yes, a function because every vertical line would only intersect once. So let's look at what these problems look like in HAWX, actually. So in HAWX, you get something that looks like this. Here's a graph, and they want to know, consider the following relation, give the domain and range. And then part 2, they're going to ask you, is it a function, yes or no? So domain and range. The domain is the stuff that goes in, the range is the stuff that comes out. The domain is the x's, the range is the y's. And actually, I'm going to add that to my notes. So that will be in the printed notes, or the the scanned notes that I upload for you guys. I'm doing it right now. All right, so the domain is x, the range is y. So I look at this picture. Hopefully you can see my cursor. I want to look at all of the x's that are covered. I can kind of imagine like smashing this down onto the x-axis and what it would look like. Well, it would look like, so all this stuff is just going to come down, or maybe think of what shadow is cast, right? So if I shine a light from the top or bottom, what shadow is cast along my x-axis? Well, it looks like -1 all the way up to 3. And you have to ask, do I include those endpoints or not? Since I have a solid circle, then I should include them. So my domain will be -1 up to +3. When I do my range, I'm doing the same thing. I'm thinking about what shadow would be cast on my y-axis. So I shine a light over here, what shadows cast along my y. So -2 up to 4. Again, same question. Do you need to include the endpoints? In this case, yes. Another way I talk about domain and range is I imagine walking along the x-axis. When do I first encounter my function, and when do I last encounter it? So here, you know, function stuff is drawn, so even though there's nothing along the x-axis at this point, like there's no stuff drawn on the x-axis, my function has a value there. Okay, or my relation, I should say. All right, so that's good. So the question, is it a function? Yes, no. Since you have a grid, this is pretty easy because the grid has a bunch of vertical lines on it. If any of those grid lines intersect the graph more than once, it is not a function. So I can see right here, bam, bam, not a function, right? Because I have the top and the bottom of my little egg, not a function. So they ask, identify 2 ordered pairs as proof. So give me 2 points that justify the fact that it isn't a function. In the same way in example B that we just did, I circled those 2 points that were on top of each other. So here I can list 1, -2, and then 1, 4. All right, dun da da, done. Okay, so let's look at this one as well. Determine the domain and range for the relation. So domain is all of the x's, range is all of the y's. So if I cast a shadow, what x values are obtained? Well, only this one, right? 3. So that's just, oops, just the set 3. For my range, I've got these arrows, and that means go on forever and ever and ever and ever, right? So if the arrows go up to positive infinity and down to negative infinity for my y's, that means my range, oh, it doesn't let me type like that, okay. That means my range is all of the y's from negative to positive infinity. So that's what I have to enter. And since infinity is not a number, we never include it. So submit answer. The last question is, of course, is it a function? Yes, no. This is a vertical line, so obviously it's not a function. You can pick any 2 points you want. All right. I want to do one more. Yes, this is a good one. So is the graph a function? Yes or no? So this one, this actually we're going to talk about in a couple sections. This is called the parabola, and it comes from squaring stuff. So my vertical lines are not intersecting more than once. So function, yes, it is a function. Oh, they didn't want to know the domain. Oh, yeah, they do. Okay, good. So domain. The domain is all of the x's. Now I can imagine as this gets larger, right? This like, I don't know what else to call it other than a parabola. Bowl, this bowl. This bowl shape is opening more and more and more and more, right? So it's gonna get wider and wider and wider. And I can imagine if I zoom out more, I'm gonna get more of my x's covered. So this keeps going forever. So all of my x's are going to be covered. So my domain is all reals. My range is the y's. So if I were to collapse this onto the y-axis, it goes all the way down to negative infinity. Sorry, I'm touching my screen like you can see my finger. I go all the way down to negative infinity, but it doesn't go up to positive infinity. It stops right here at 3, right? So negative infinity up to positive 3, and you do include 3 because this is a solid line. All right, done. So my big summary for this section is Functions and relations differ by the fact that functions have one output to every input. So one thing goes in, one thing comes out. There may be more than one way to get to an output, but when you plug something into your machine, you know what's coming out. That means you have the vertical line test. If a vertical line intersects more than once, your graph does not represent a function. Domain is about x values, so imagine what shadow the graph would cast on your x axis for the domain or on the y axis for the range. Draw this thing if you have like points. Sometimes this is easy to see whether or not it's a function.